Hello everyone and welcome to a new sprint review from the Eclipse JKube team. Regarding JKube, we've worked on the underlying architecture to deliver the missing Helm features. One of such features, linting JKube generated Helm charts, was also implemented during this sprint. We've also replaced some of the opinionated JKube resource labels with those that Kubernetes recommends. Both these features and a few more were released in version 1.16, which we announced last week. For the Fabricate Kubernetes-client, we added support for the OVN networking API. It's also worth noting that we added support for Bouncy Castle FIPS security provider as an alternative for the generic Bouncy Castle provider. And as usual for both projects, we spent some time dealing with bugs and general maintenance tasks.
Hello everyone, this is Rohan from Eclipse JKube team. Today in this demo, we're going to take a look at JKube Buildpacks integration that has been added in a recent JKube release. Cloud Native Buildpacks is a very popular framework that lets you convert source code into efficient production-ready container images. It does that by using unique approach of Buildpack Builder images. Buildpack Builder images encapsulate components required for building container images. It automatically detects application source code, gather the required dependencies, and build it into an image. There are various communities maintained Buildpack builders that are designed for popular frameworks and are kept up to date. Starting from JKube 1.16.0, along with currently available Docker, Jib, and S2A build strategies, we have introduced a new build strategy option for Buildpacks. This new option would delegate image build process to Cloud Native Buildpacks. With this integration, user can easily switch from one build strategy to another build strategy depending on his use case. For example, user can use Buildpacks build strategy when he is deploying his application in outer loop to generate a fine-tuned OCI compliant container image. While development, user can rely on Docker build strategy in his inner loop. This can help user utilize best of both tools. JKube does not require on-pack CLI to be already installed in order to run Buildpacks based build. Generated Kubernetes manifests are also compatible with the generated image. Alright, so let's take a look into this in action. Okay, for demo, I'm using a really basic Spring Boot application. It's a Spring Boot 3 application and it's using Kubernetes and OpenShift Gradle plugins 1.16.0. And it has a very simple controller that prints a hello world message at the root endpoint. Alright, so let's try to deploy this application to Kubernetes using the Kubernetes Gradle plugin. First, we'll start by building the container image, but this time we'll use the Buildpacks build strategy. So let's override the build strategy using JKube build.strategy property and set it to Buildpacks. Okay. This would delegate the build process to, this would download the pack CLI and start the Buildpack build process. So by default, we use the Paketo Buildpacks that are quite well known for building container images using Buildpacks. So it has started the process. Alright, so the process seems to have finished. So let's try to inspect the image generated. What's the name? JKube Buildpack demo. Okay, so as you can see, the image is quite lightweight in size, only 277 megabytes, which is small when talking about Java based container images. Let's try to inspect the image a bit more. Docker inspect the image. So these are the layers inside the image. As you can see, there are more layers in the image generated by Buildpacks due to its modular nature, and it seems to have added some labels like open containers, image ref, image version, and there seem to be some labels with respect to Buildpacks. Alright, so let's try to we have built the container image, so let's try to generate the manifests and apply these to my Minikube cluster. So we'll run the resource and apply tasks. Okay, so it has generated the manifests and it has applied them to the cluster as well. So let's check on the pods. It's coming up. Okay, let's check the service and let's check whether our application is running or not. Alright, so our application seems to be running. So this concludes the demo. Thanks a lot for watching.